Putala, good morning to all of you. Welcome to today's Thermodynamics session. Continuation from the previous lecture. So today our focus is on understanding transport in refrigeration system. Hello? Yeah. So once you understand the transport in refrigeration system means you know refrigeration system. So that is the point. Yeah. It's after end of the session, you should know refrigeration system very well. Okay. So that is the so let's say what let's say what's the understanding transport in refrigeration system means. Do you see the transport clearly? Yeah, that is the first thing. Do you see the transport clearly? So right side you have the refrigeration system. Left side you have the earth moving cycle. Okay. Right side you have the cooling cycle. Okay. Right side you have the cooling cycle. Left side you have the earth moving cycle. Can you remember these two cycles we have learned? I believe you can remember this. Okay. So do you see the transport clearly? Transport in heat removing and the earth removing. Know the transport clearly. Do you see the transport clearly? Can you see? Can you see the transport clearly? Puta the mechatronics are the mechatronics students there? Tarindu Puta manufacturing the mechatronics there. Manufacturing Puta mechatronics sign at the beams are manufacturing the Chaturoko mechatronics site message.
Mechatronics in other.
In one,
Mechatronics in other.
Hari. Okay. Go to them. I think you have some good feeling of this too. It's almost similar. I believe you can remember this. If I go back to the previous, yeah, this is the earth removing project cycle. Collecting of soil, excavation and collection going on. Then the loading, dispatch, unload, empty return of the transport. That is going as cycle 2, 3, 4, and 5. Okay, this is for the earth removing. I believe you can remember this. Okay, the 5 steps. Normally, in the cooling cycle, the collection people neglected, but collection is extremely important. They just think of 2, 3, 4, and 5 only, but practically 1, 2, 3, 4, 5. Okay, so you have the collection, loading, dispatch, unloading, and return of transport. So from 2 to 5, it's being operated in a cycle. Okay, it's operating in a cycle. Loading, dispatch, and sending the transport for unloading, then return. Okay, Returning is important because if no returning, you cannot load it. Yeah, that's why. So returning is very important. Otherwise, you have to have new trucks. That is not practical and economically viable. Same way, heat removing cycle. This is the example we took. Okay. So the heat collection is here. For loading, then the loading, unloading, okay. Sorry, loading, dispatch, okay. Loading, dispatch. So unloading and return transport, you can see. Loading is taken place here, number 2. At the evaporator, we call anyway cooling unit. Then transport is dispatched by means of compression for unloading. After unloading, this will be returned for loading through the capillary. This is for the vapor compression systems. Later, I will let you know what vapor compression means. And generally for refrigeration systems, you will learn this. Okay, Buddha? Yeah. Yeah. I believe you are very familiar with this now. So 2, 3, 4, and 5 on a cycle. Okay, 2, 3, 4, and 5 on the cycle, and there are corresponding 4 components for this. Okay, these are real components I put here. So 1 is continuing there, the excavating or collecting of heat. Then 2, 3, 4, 5 in a cycle. Okay, so these are the 4 major components. We are going to learn this today. Don't worry. Yeah. 4 major components corresponding to 4 major processes. Those are in the cycle. Okay, loading, dispatch, unloading, and return. And we have learned about this. The heat interactions even we have learned. The loading, heat, QL. Okay, QL is the loading heat. For the dispatch also, there is some heat or energy addition to the transport. Loading means energy, again, loaded to the transport. So energy is taken by transport, that is QL. L means loading. Then C means at the compressor also when do the dispatch. Some heat is added to the transport, that is QC. So transport is now with more energy, QL plus QC. All should be unloaded at the unloading point. So QO is, okay, QO is QL plus QC. Okay, so QL, yeah. So there is a heat balance also here. WC work, okay, yeah. So QL plus, I have to do some correction here maybe. Sorry, QC is the leak. So heat leak from the system is QC. QC is the heat leak because compressor is hot. Okay, because compressor is hot, part of heat is dissipated out from the compressor. Compressor is hot because the compressor motor is here inside for this case. So QC is out. So WC is the work in, QC is the work out. So WC minus QC. Amount of energy is input to the transport. Okay. So QL plus WC minus QC is QO. So your performance of the system is heat removed QL divided by the work done for dispatch WC, that is the work into the system, QL plus QL by WC. Okay, I believe you can understand this very well. So further here, put some temperatures. So let's say the at the loading point, transport temperature is 10, room is 25. So 25 to 10 means higher temperature to lower temperature, heat can flow through. Thereby QL is transferred to the transport. After that, energy loaded transport comes for dispatching. Okay, now it's for dispatching. Here for dispatching, the compressor component here, there is a work done. Okay, work done. Then අපි refrigerator එකේ හිම අපි current එක දීපුවාම අපි සිංහලෙන් කිව්වොත් if you supply power to the refrigerator, you can hear that one component starts functioning, not one, of course, all. But here mainly the compressor receives that energy or work, okay, from electrical energy through the motor. There is a work done, let's say WC, and out of that, because of the high temperature 70, let's say, heat is dissipated. Those portion of heat is releasing to the ambient. Okay, so WC minus QC is added here, okay, to QL. So again, the QO is QL plus WC minus QC. So COP is QL plus WL. Yeah, so you can see the same way. Okay, 4 components are here corresponding to 4 processes in the cycle. Okay, 2, 3, 4, and 5. I didn't mention 1 here. 1 is naturally taken place. Okay, when the fan blows through evaporator and passes through the load, you can see some collection of heat. Okay, 5 steps are okay. Now, understanding transporting refrigeration systems. So if you understand this, you are done. So this is something understanding to the fullest. You have to think about this and you have to pay some attention. That is very important, and have some imaginations as well. And if you have any questions, please ask. Okay. Understanding transporting refrigeration system. So I'm going to ask several questions from you. Okay. So if you can say yes to those questions, or if we discuss these questions today, that helps for understanding. Okay. The first question here, of course, the question, the main question of all. Do you see the transport clearly? Okay. Do you see the transport clearly? Bimsara, can you see the transport clearly, Puta? I'm asking because at least I have to have some dialogues today. Can you see the transport clearly? Or do you see the transport? Oh, Puta?
Yes, sir.
Very good. Chatura Kohamad?
Yes, sir.
Okay. Yeah, we will see how well we can see. Madhushani, Puta Tirnada? Kohamad, can you see the transport? Madhushani looks silent. Hishan, Tirnada Puta? Hassan, ne? Hashan. Hashan Tarak. Yeah. I believe you have little understanding. And let's look into these questions. Okay. सामान्य प्रश्न गत्ता මේ ප්‍රශ්නය පොඩ්ඩක් ෆීල් කරන එක හොඳයි තීරුම් ගන්න පුතා. Okay, so this is the yeah. This self-answering questions. Do you see the transport movement? Do you see the moving of transport? Earth moving? Yes, we can see the movement of trucks. So transport we can see clearly. Let's say we can. So how well we are seeing, we have to look into further. And in cooling cycle or refrigeration cycle or heat removing, this working fluid or refrigerant, okay, as we discussed in the previous examples, you can see refrigerant receives the heat at the loading, then dispatch for unload, okay, and unload, after that return. So loading, dispatch, unloading and returning taken place at this cooling cycle connected with these 4 cooling components. Okay, so loading is the energy receiving or energy transferred to the working fluid or refrigerant, we call. Refrigerant means it's from the refrigeration or cooling. So the working fluid we call refrigerant. So after receiving the heat at the heat loading point, okay, this refrigerant is moving, it has to move. So it is looking for unloading that heat. Okay, it is looking for unloading that heat. After unloading, this refrigerant is looking to return for loading. Example like say in a blood circulatory system. ශරීරවල සත්තුන්ගෙම තියෙනවා රුධිර සංසරණ පද්ධතිය, blood circulatory system. So this system is powered by heart. එතනින් තමයි receiving and dispatching ඔක්කොම කරන්නේ heart එකෙන්. So heart is receiving and pumping. So that's how the system is getting a power. කියන්නේ සිස්ටම් එකේ මේ බ්ලඩ් ෆ්ලෝ එකට පුතා පවර් එකක් ඕනේ, එනර්ජි එකක් ඕනේ, වර්ක් ඩන් එකක් ඕනේ බ්ලඩ් ෆ්ලෝ එකට. So work done for flowing blood or the power needed to circulate the blood is provided by heart. Similar way, for this refrigeration circulatory system, you need a heart-like thing to suck the refrigerant and to pump it. Natural understanding. Yeah? So that's what we call here compressor or dispatch. So dispatch, you have to receive it. Without receiving, you cannot dispatch. So refrigerant, after loading with heat, this compressor receives that refrigerant with that heat load and then dispatch to the unloading point. Yeah. So what happens is, when this dispatch, because of that process, little extra energy is loaded to the system again, because work is done. After receiving, you dispatch it. Okay. And then it is going for unloading because of the dispatch power. The power of this circulation from the compression. So there is some added energy after dispatching or during the dispatching process. So after unloading at the condenser, the refrigerant is returning back with the same initial condition with unloaded energy to again load the energy or the heat. And then again the compressor received this and sent for unloading. Okay. And after unloading, returning. Loading here, compressor receives this and sent for unloading. After unloading, return this. So the power for this circulation is because of the compression. Okay, and you can see the flow of refrigerant. So do you see the transport movement? Moving trucks obvious, you can see. You can see the transport movement. Dispatching with full of load. After unloading, empty truck returning, full loading. Same way, you can see the loading the heat to the refrigerant, then the heat loaded refrigerant, dispatch, okay, and then unloading after that return. You can, for the earth moving, you can visually inspect this. You have to think about that. And for the refrigeration, this cycle, seeing the transport, you have to have little extra knowledge. Sometimes to see the unseen. See, truck eකට ගල් වැලි පට වෙනවා පේනවා, but for the refrigeration system, still you can see, but you have to have little extra sense of that. Okay. Do you see the transport when it is ready to load? That is one of the things we have to make sure that we see the transport clearly. You have to see the movement, yes. Are we seeing the transport when it is ready to load? Earth moving, yes. How about the heat moving, heat removing? We have to understand this. Do you see the transport while being loaded? Transport eකට load කරන වෙලාව පේනවද? Can you see the transport? load කරන වෙලාවේ transport එකේ තත්ත්වය පේනවද? For earth moving, yes, you can see. Heat removing, can you see this? Yes. So we have to see with the same clarity. Earth moving එකේ transport එකට heat එක load කරන clarity එකෙන්ම ඒ පැහැදිලිකමම තියෙන්න ඕන heat loading situation. Okay, in the situation of heat loading. Fourth question. Do you see the transport when load is dispatched for unloading? Do you see the transport when load is dispatched for unloading? After loading, it's been dispatched. In the refrigeration cycle, we have to see that as well. Yes, dispatched for unloading, which means you should see the full energy loaded transport. That is very important. Do you see the transport when reaching the unloading place? Is it fully loaded or came empty? We have to see that. Yes. So now I'm asking, earth moving, you can see, heat moving also, you should see with the same clarity. Then you are done. Okay? That's why understanding technology is something not memorizing. It's a way of seeing the things. It's a way of seeing the things and mostly seeing the things unseen. Okay? 6. Do you see the transport when load is being unloaded? Again, load එක unload කරන වෙලාව කොහොමද මේ transport එක? Can you see it? කොහොමද මේක? How it's taken place unloading? So you have to see that. Do you see the transport when unloading done? So I'm really sharing with you how to see the technology in complete ways. Once you know this, power plants, even steam cycles, nothing. Okay, once you see this, you know what to see. So you see this here for the thermal power plants, steam cycles, you will see the same. That is very easy. Okay. Do you see the transport when loading is done? Do you see the transport moving after unloading? Okay. 9. Do you see the transport reaching the loading point for loading? Once you know these things, you are done. Okay? You are done. I can try to show you, but you have to see this. Okay, I can help for you to understand, but you should understand this. Okay? You should understand this. Yeah. That's why that is very important. So joining the class is extremely important. Then only you can feel this. So there are 9 questions. This is question number 1. Okay. Moving trucks, yes. You can see the truck itself, whether it is empty or it is fully loaded, or it's being loading, or it's unloading, or sent for dispatching and returning. Moving truck. See the transport movement, yes. Okay. Flow of refrigerant in heat removing, how to say yes? Okay, so that is the challenge. Flow of refrigerant in heat removing, how to say yes? And today's session we have to understand this question 1 to 9 to the fullest. Yeah. Then it is done. So flow of refrigerant in heat removing, how to say yes? In this diagram, in this black box, black square, fan is placed with the evaporator here, just to remind you that the collection and loading is taken place. Okay, that's why I put a fan here. Even in unloading at the condenser also fan is there. So these are some auxiliary components combined with the main part of the condenser. So together it has some heat unloading. Okay, unloading. The compression, the dispatch, the heart of the refrigeration, refrigerant circulatory system. Okay, returning through this. Okay, returning through this backfold loading, that is a metering device. Later we will know about this. So I put this text in this way. Yeah. Let's say, understanding this, can we say yes for seeing the flow of refrigerant in heat removing? Okay, so I just put in this way. In the heat removing cycle, 4 of the 5 key processes. So I'm reminding you the 5 key processes because that is very important. 4 of the 5, so I'm mentioning here only 4. Loading, yes. Dispatch, unloading, and return ready for loading. So I just put that return ready for loading. Okay, otherwise just simply returning is no point. That should be return ready. That's why return ready is passing through a capillary. Okay, so 4 of the 5 key process. Yeah. Refrigerant through respective components. Yeah. Okay. Flow of refrigerant. Which are connected in a proper sequence. I have to add some little words here maybe. Yeah, in 4 of the 5 key process, refrigerant passes through respective components, which are connected in a proper sequence. Okay. Refrigerant in 4 of the 5 key processes. Refrigerant passes or flows through, let's see. Flows through respective components which are connected in a proper sequence. There is a sequence. Okay. Sequence. Loading, dispatch, unloading, return ready for loading. Okay. So the 4 of the 5 key processes. Okay. So the Refrigerant is, of course, loading heat to the refrigerant, dispatch the refrigerant, unloading heat from the refrigerant. Refrigerant is returning ready for loading. Okay, I'm repeating that so many times already. Okay, I have repeated it. So these are connected in a proper sequence. These are connected in a proper sequence. To take and place this process, make harina sequence එකකට තියෙන, which means after loading, okay, after loading, you cannot simply unload. There should be a pump like thing, okay. The blood circulatory heart. So here, for the refrigeration circulatory, you have to have the compression. Then unloading, return rate. Okay, good. Agreeing about that. These four processes are operating in a cycle, and there are corresponding components through which the transport is flowing. Okay, and these components are sequentially connected. There is an order, sequence. Loading, dispatch, unloading, return, ready. Okay, so transport, getting loaded with heat, received by the compressor and dispatch it. For unloading, after unloading heat in the refrigerant is return ready. So you can see that there is a transport taken place. So now you can see the transport movement. Okay. So you can, at least now you can see a little yes, not a big yes. For the question, do you see the transport clearly? You have a little answer. Okay. You have a little answer for this. Okay. Yes. When you observe these moving trucks, okay, yeah, you have to see the loading and all loading, unload, loading, dispatch, unloading and return. So there can be observation points. Okay, same way for refrigerants. Observation point, I just put here. The refrigerant entering the heat loading component after passing through the metering device. It's an observation point. You have to make sure that fully unloaded the refrigerant should entering the loading should be fully unloaded of heat. Okay. Same way, truck should be returned ready to load, fully unloaded, potential to load fully. Okay, which means the truck, okay, when it is reaching for loading, you have to fully unloaded the truck. You have to only half load. So you have to make sure that fully unloaded. Means fully unloaded means potential to load is fully. Potential to load fully. Full potential to load. Okay. Same way refrigerant should be returned ready to load is fully unloaded. Okay. They are the heat. Fully unloaded and potential to load is to the fullest. Okay, potential to load is to the fullest. Is to the fullest. Yes. Oh, fullest potential. I take this up. Fullest potential. To load. What here? Collected heat. Fullest potential to load the heat. So this is an observation point. Okay. So refrigerant or the refrigeration transport. Yes. When reaching the loading, there should be a fullest potential to load. Okay, here.
Excuse me, sir.
Yeah, Buddha.
Sir, we can't see the presentation.
You cannot see the presentation, my goodness. Oh. Thank you for mentioning it. Yeah. පුතා ගොඩක් වෙලාද මේක කීවා මේ දැකලා නැතුව? Just now or a while ago?
While ago, sir.
Okay, thank you very much. Just remind me because these slides, you have to see these slides. That is very important. Yeah. So, yeah. You can very leisurely, but with a good focus, you can think about this. So we are slowly learning. Yeah. So the earth removing is helping us. Okay, very good. So refrigerant should have the fullest potential to load. So that's the question 1. Okay, do you see the transport? Yeah. So this is another one. So the another question is this one. Do you see the transport when it is ready to load? For question number 2, you have to see this one. Do you see the transport when it is ready to load? So this is the question number 2 actually. Question number 2. So we should see the transport ready to load means the transport should have the fullest potential to load heat. Do we see that again? Sampurna empty the Indone transport is fully empty with a very good potential. A very good capacity, sufficient capacity. That is not enough. That may not be that suitable. Okay, so you have to understand how should be meshing. Okay, and the potential should be fullest, fully unloaded. Okay, to have the fullest potential to load. Okay, then we can see, we are seeing this. Do you see the transport when it is ready to load? Means the fullest potential to load should be there, means fully unloaded heat. Okay, under the same. So I'm focusing here. Do you see the transport when it is ready to load? Yes, we know that there should be fullest potential, but what this fullest potential means? Full potential truck empty in road. Empty, it should be fully empty. There can be the size big enough, just sufficient size, the capacity empty space. Yeah, let me go through one by one, right? Yeah, so how do you see the transport ready to load? Because question is, do you see the transport when it is ready to load? That is a question. How do you see the transport when it is ready to load? Yeah. So for moving trucks, when the truck is ready to load, empty truck at the point of loading. So this is empty truck is at the point of loading and facing the backhoe maybe or the loader. So heat removing cycle. The refrigerant entering the heat loading component or evaporator after passing through the metering device. Metering device means this one. I'm circling it. After passing through the metering device. Because this refrigerant, it cannot be a smaller truck, also it cannot be a big truck. Okay, it should be just nice in size. Yeah. Truck, you can see the size in the truck of the size, but transport of refrigerant, the capacity, you have to think little more that. Okay, let's read this one. Truck should be returned ready to load, fully unloaded and potential to load fully. Refrigerant should be returned ready to load, fully unloaded, potential to load fully. Okay, පැහැදිලිව තේරුම් ගන්න. So earth loading, okay, at the loading bay, earth loading ready transport, you can see here the full loading capacity should be there. Means empty space to load. Truck should be empty when it is ready to load. So empty means what extent or the capacity. Okay, capacity. And the rate of loading, yeah, how fast this can be loaded. And then how fast this can be dispatched. Faster loading, faster dispatching. So the rate of loading also important. Yes. Okay. Rate of loading also important because rate of the loading again related to rate of dispatching. Yeah. And you have to have a capacity as well. Okay, capacity. So here heat loading need to address. Okay. We have to address the capacity for heat loading. We have to address the rate of loading. We have to address the rate of dispatching. And now you can slowly see how well you have to follow this. Yeah. So the refrigerant, the capacity for loading. Okay. Capacity for loading. How to have a capacity for loading? Yes. Have a capacity. What are the parameters? So what are the things that are connected with the loading? Yeah. Empty refrigerant, of course. Heat unloaded refrigerant or empty refrigerant. That's wording is okay. Energy emptied refrigerant or heat empty refrigerant. Okay. But of course, there is an energy, but it has a potential to receive energy. Okay. So we will see what happens. Okay. Yes. Capacity. Okay, size of the transport. So the truck movement rate, maybe one truck in 1 minute, or two trucks in 1 minute, or three trucks in 1 minute. If it's a standard truck, or smaller trucks, maybe 10 trucks in a minute, or maybe parallel loading. So this transport moving rate is important. Okay, for refrigerant, it's a kind of matter. Padartha swabhavayakne. So this matter absorbs heat. So flow, or the rate of the flow of matter, we call this mass flow rate, is important. Flow rate or mass flow rate, because heat is being loaded into the transport is taken by the mass itself. Earth moving එක කියන්නේ empty truck එක. Heat removing එක කියන්නේ it's a mass flow. Transport is a mass flow. Refrigerant flow, it's a flowing of a kind of special matter. This is like awakening, you know. You see the transport. Earth moving, empty truck. But in heat moving, you have refrigerant is a kind of mass. So there is a mass circulating. So mass flow rate is important. Okay. And assure that the mass of the transport is fully unloaded, heat unloaded, or when it is ready to load. Okay. And now you have an idea that yes, mass flow rate is important, and the loading capacity of that flow is important. Let's see, for example, let's see, through the loading or evaporator, 10 kilograms of refrigerant flow through in 1 minute. Let's say in 1 minute, 10 kilogram refrigerant. So if you think this is something like trucks of 1 kg, there are 10 trucks in 1 minute. Let's say 1 minute, 10 kilogram refrigerant means in 1 minute, 1 kilogram of 10 times means 10 trucks, something like that, going empty to get load. Okay, so the truck flowing rate, the mass flowing rate is important, and per truck, the potential of energy receiving or energy loading is important. Okay, yeah. පුතාලා තීරණාද කීප එක වැඩිපුර පැහැදිලි කරන්න ගියත් ඔළුව අවුල් වෙනවනේ. තේරුණාද මං කිව්වේ, let's say through this evaporator, if 10 kilograms, let's say, flowing in 1 minute, so this 10 kilogram flowing during a time span of 1 minute means, okay, there should be a uniformity, means starting 1 minute and end of 1 minute, the flow through the evaporator is 10 kilograms. It is something like 1 kilogram of tens of 1 kg. Tens of 1 kg. So 1 kg, 1 kg, 1 kg. And likewise, in 60 seconds or in 1 minute, tens of 1 kg pass through this. අපි හිතමු 1 kg එකක් කියන්නේ 1 truck කියලා. 1 truck, 2 truck, 3 trucks, 4 trucks, likewise 10 trucks. 1 kg trucks in 1 minute. This is not mentioned here. Okay, I think I will do that in a new slide here. So then one truck, how empty is that? Or how big is that for loading? That is very important. How big is that for loading? Okay, let's say, let me do a new slide. Let me do a new slide. Okay. Later I will explain this, don't worry. Yes. worth spending for this. Huh? Truck 10. Okay, 10 truck. Truck 9. Truck 8. Truck 7. Truck 6. Truck 1. Change this. Okay. Each truck one kg. Okay, 1 kg mass. 1 kg mass. Okay, let's say now this direction where the trucks are moving, okay, moving one behind the other, one behind the other. Okay, one behind the other. Let's say this is the loading point. Okay, let's say this is the loading point. Evaporate. Evaporate. The flow rate. Flow rate. Flow rate, let's say, as I mentioned, 10 kilogram per, let's say, minutes. Okay, I just put 10 kilogram per minute. So, which means, let's say, 10 kilogram per minute. So what happens is, okay, so if you imagine 1 kg per minute truck, truck 1, truck 2, truck 3 likewise, 10 trucks of 1 kg. Okay, all 1 kg trucks. 1 kg. Even you can have better imaginations. Huh? Yes. So let's say the flow rate through evaporator. Okay. Through evaporator, flow rate. What flow rate? Is the transport rate. This is the transport. Transport flow rate. Means through this evaporator, in 1 minute this is, okay, 10 kgs means removing is, okay, 10 kg means one truck, okay, moves out, okay. So this is the way this direction this moves, and you can see one truck move out. Then at the beginning of 6 seconds, first 6 seconds, one truck move out. Second 6 seconds, second truck move out. Third 6 seconds, third truck. So what is enter here? So 1, 2, 3. You can see fourth 6 seconds, the fourth trucks, because fourth 6 seconds, truck 4 will be here at the exit. Okay, so truck 4 will come out. See, next 6 seconds, truck 5 will come out. After that, truck 6 will come out. Truck 7. Truck 8. Okay, truck 8. Take a little time, but if this is a one-time learning, that time is worth it. Okay, so the 10 trucks comes the last. Okay, so first one is well ahead. Tenth just come out. Okay, same way. So this is the starting of the minute. Okay, starting of the minute. Truck 1 is coming out in 6 minutes. It takes 6 minutes. And once truck 1 comes out, truck 2 will come to the front. Truck 3 behind, following like truck 10 will come here. And the further trucks will follow. So maybe this one after unloading, this will go back maybe. Let's say after unloading, this will go back. Let's say if this is going back after unloading, this will go back. Okay, very interesting. So the first truck comes first for unloading. Okay. Likewise, 1 kg trucks. That's why. So when you analyze the transport, it is okay just to analyze the condition of 1 kg. That is one thing. And how fast this 1 kg move. Okay, so that is what you should understand. So this one 1 kg truck, you have to consider two things. Okay, one is how fast. Example, for the example, I just take 10 kg per minute and I take 1 kg of 10 trucks. So in every 6 seconds, one truck is coming out, because coming out takes time. So in every 6 seconds, one truck is coming out. Okay, that's it. So every 6 seconds, one truck. So how fast is important? Let's say the other is the capacity of the truck, loading capacity. Okay, capacity. So the truck movement, how fast the truck movement, the transport or the truck movement. This can be a 1 kg truck, or even this can be 1 gram truck, depends, or 5 grams truck. It depends. How fast the truck movement. This is we call mass flow rate. Okay. Mass flow rate. Okay. And the heat loading capacity. This one we mention as QL. Can you remember? Heat loading. Okay. Heat loading. Capacity. QL. And we call this, so this is per truck. Per truck or of a single truck. Per truck or of a single truck. We call this refrigeration effect. Okay, refrigeration effect. Okay, how fast means mass flow rate. Okay, how fast means mass flow rate. Then the loading capacity per truck for a single truck. We call it refrigeration effect. Here we are taking 1 kg, a single truck of 1 kg. Two items. Okay, two items. So how fast the truck is moving, same way. Even earth moving, earth removing. how fast the truck is moving, truck movement. Yeah. So one day maybe you're operating, let's say 1 hour you're operating 10 trucks. Same size ones, if you're operating 1 hour 20 trucks, your capacity of removing earth is doubled. So that is earth removing effect. So refrigeration effect means heat removing effect. Heat removing effect. Okay. Heat removing effect. Heat removing effect. Can you see this clearly in your screens, Putana? Sometimes you are using small smartphones, maybe with a smaller display. So can you see this, Putana? Can you imagine? So loading and unloading only mentioned here. Okay? Loading and unloading. So here you can have the dispatch. Here you can have the return ready, the capillary or the metering device. Then this is complete. Okay? So how fast moving? Okay? And the effect of heat removing means for 1 kg, how much of energy can be loaded? That is important. Okay, Putra? Ternari? Okay. So let's move forward. So before forwarding, I add some little components to that. Dispatching. Okay. Little noisy here surrounding. This helps for the returning ready to load. This helps the metering device. So these two are very important. These two are very important. And let me take this out. Then this has bitter meaning. Okay. And then evaporator. Let's see. I will take this. Because different ways I am going to put this in your mind. Evaporator. Let me put it here. Your condenser. I will take from this. Nice. Okay. Nice. All in one. Is it okay? Yeah. So I will take a new one. Slide. And okay. I will put this some figures. You have QC, you have QN, you have W, you have QO. QL loaded here. These are in the trucks. Okay, these are the trucks. QL. Don't worry about the units yet. Okay, don't worry about the units. Later we will work out the units. Loaded heat. Okay, it's okay per kg. Don't worry, eh? Per kg. QL is here. QO is the energy unloaded. Let me move this a bit up. This is Q. Okay. QO. This QL, it is here. That is fine. And this QL is somehow receiving. Okay. Here. CQL is here. That Q will pass through here. WC I will make that smaller. WC is here. Very nice. Okay. This QL, WC, and this QC is heat released from the compressor, because there can be, so I will make it smaller. I will put that as well. QC. By now you should know what WC and QC is. QC. QC is I will put QC. This QO is here entering is equal to receiving QL compressor work WC. Actually just W is enough for compressor work. Anyway, I put WC. Minus QC. Okay. That is QO. Okay. So this is entering QO. QO entering. The same QO released. QL, this is entering here. So QL plus WC minus QC. QC is the energy released out to the ambient from the compressor. That is technical point. Okay, Buddha? QC is a technical point. So here you can see QL, WC, QC. Okay. The capillaries, so nice. Now you know that the mass flow rate or the flowing of truck movement rate, that is per kg rate for refrigerant, and the refrigeration effect. Yeah. Okay. Very good. Try to understand this very well, because I'm trying to naturalize this knowledge for you. Understand? I'm trying to naturalize this knowledge. දෙවරක් දෙක හතරයි කියපුවම ඔබ හිතන්න දෙයක් නැහැ. ඔබ හිතලා ගන්න ගියොත් එහෙම ගණන් හදන්න වෙලාවක් තියෙනවද නැහැ? ඒක නේද? චක්‍රේ හිත පාඩම් කරන්න ගියොත් වැඩ කරන්න ගියොත් you cannot do that. Same way, if you have to think always about this, you cannot develop the things. You have to always think about this, that's all. So I want to help you to have everything in your fingertips. No, yeah, sorry. It is too tough. Okay. I'm rearranging this. Okay. I'm rearranging this. Everything. This is your QL. This is your arrow here. So I didn't do any change. Eh? Yeah. Here is your compressor. The dispatch device. This is the one, same like in the heart. Okay. Supply the necessary signal interruptions. WC is here. I'm using the same. Okay. So QO is here. QO is here. Any missing arrow? Yeah, okay, I will take this. QO is here. WC is here. Okay. For WC, I will take another arrow. Yeah, for WC, I will take another arrow. With that black arrow. Yeah, here. Well, I could take this one. See, you can see this. Huh? You can see this. So I will take that here. Compressor is not here. WC. I will take. So we're done on the compression. Okay. And your QC. QC. I just put aside. Okay. and you have a QO. QO. And QO is being received by condenser here, and it's being released. The pin one is slide. Hope I have shared it. Yeah. Okay, released. So what we release? QO. So the same QO is here. So QC also released. I keep this aside. So focusing on the dispatch. So QL, you are receiving. QL from where? Here. Okay, here. QL. Writing for QL. Beta I take from here. Don't worry, everything makes your knowledge more natural and comprehensive. So you have to be very patient. So otherwise, I also can just put a PowerPoint for you and tell some words, and I can close the class. So I'm not doing that way because I need you to understand this. Okay, well, this way, this is coming. Okay. Interesting, eh? As you see, I'll put this here as well. So 1 kg, I put it aside. What is this? Also QC. Put it there. One more thing in mind. This heat is returning to ambient. This is 30, let's say. 30. Okay. Same way, let's say this is an aircon solution or whatever. Low temperature solution. I can see some 20 degree and 25 degree. I will take that also to the same picture. Ten degrees well inside. 25 is the ambient. To make it little big. So now you can see that this 25 degrees C and this 10 degrees C. Okay. And the point is here that heat at 25 loading to 10 degrees C. So this arrow should connect to this. That's why you have to follow this thinking approach. And this arrow should connect to this. Okay. This means what? The 30-degree ambient. Okay, this 30-degree ambient. This is 30, so let me put it in a bit darker. Yes, 30. Same way here, refrigerant. Here it is bit higher temperature for sure. See, 45 degree. So I will take that as well. 45 degree. 45 degree refrigerant. So this is from the refrigerant at 45. It's very nice. Refrigerant at 45. This is KO. This is the hotter one. I will change this to this color. This compression may be around 70. I can remember we have the figures for this. Let me put that as well. Anyway, this is not the final. We are exploring this. We are exploring this. Compression 70. Top and bottom 55. Anyway. See, more than 45. So maybe higher quality heat type QC. Okay. Now you have to follow this very well. Right? And even this QC is going to surround it. So it's the same. Okay. It's the same 30. It's the same 30 going to 7. Okay. It's the same 30 going to surrounding. Put this as QC. QO, I will put it here. High temperature mass. High temperature. Okay. Quite interesting. You can see dispatch, unloading, loading. Ready return also we can put it here. Return ready to load. It's here. I just connect only. I just using a line. To 10. Very nice. Okay. Very nice. So this is the way you can say this. Understand? It is good. Okay. So if your focus is on the compression and the receiving QN, at 10 degrees, 10 degrees. WC compression. Okay. Quite interesting. Okay. So you have the dispatch here. I just put it just a little closer. You have unloading, return ready, and this COP energy balance. I will take all here. Unloading, just nicely placed. nice. This is true. Yes. Now you consider this for 1 kg. Okay. So truck, you have to say 10, whatever truck, 1 kg refrigerant. Truck or transport, just nice for both. It is okay. So, what is this QL? Is the refrigeration effect. Ref effect. Ref effect. Just nice. So, COP. Ref effect. Then you have to take it per truck. Okay. Per truck. QL. Okay, that is per truck means per kg. WC. Per kg work. So per kg ref. Per kg refrigeration effect divided by per kg compressor work. Because per kg compressor work means for the compressor work done that is on the refrigerant flow, so you can have per 1 kg flow of refrigerant what is work done. Okay, so you can have this. So per kg, I will take maybe small q, QL, small w. Okay, so P is QL by WC. Don't worry. Okay. Energy balance remains. This is energy balance. QL plus WC minus QC is QO. Okay. So let me take one more. Energy balance. I delete all. QL. Receiving the compression. WC receiving the compression. QC releasing from the compression and dispatching this much. QO. Dispatching QO. Okay. Yeah. Okay. See the QL receiving by compression, WC receiving by compression, QC releasing to ambient, okay, and returning for unloading. Dispatching is QO. Okay, so QL plus WC, QL plus WC minus QC, because you are releasing this before dispatching. QC is QO, that is for dispatching. Okay, that is for dispatching. Okay, that's why this is quite nice. We call this energy balance. And then again from this you can find what QL means. From this even you can find QLS. As a result of this, your QL can be QC plus QO. Okay, QO plus QC sorry, minus WC. Energy balance. write this in different ways. The same energy balance is this. L is QO plus QC minus WC. But this Q first expression is the important one because the dispatch energy is there. Okay, the dispatched energy is there. So if you need this energy, what you are receiving at the loading, that is QL, is this. So then you can have another expression, same, QL by WC. This. Okay. Yeah. You'll understand. I believe you can understand this, and there is a little lesson here. I have to do a new slide for this. Okay, let me do this. From this, I can write this way. Another slide, this is. QL plus WC is QO plus QC. Okay, QO plus QC. QL plus WC is QO plus QC. You can see that this QO is the same QO release into ambient at 30. See, this QO through the condenser comes like this because QO going for unloading and unloading to ambient. So QO also unloading to ambient 30. You can see 30 degree here. This is the ambient outside 30. So this is also 30. Same. So QC also unloading to the same, this QO also unloading to the same. So even QC is from the dispatch. QO also from the dispatching, from the compression. So I will take an energy balance of this way afterward. Okay, I will take an energy balance in this way. This QC plus QO, instead of 2C, join here, join this one. So QC plus QO. So what I will do is, Okay, WCQL, and this one I will put as QH. H means high temperature, one way. L means low temperature. So this is okay. We'll make this little smaller to get some space. Oh, that is too small. Yes, good. QL plus WC is QO plus QC, that is QH. Okay with that? Therefore, I will take, instead of QC and QO, I will put here big QH to represent both QC and QO. I will take QH here. I will take QH to represent both QC and QO. Okay, QC and QO. So this two, QC and QO. So I will represent this. And then I cut this out. Strike. Strike. So no more this one. QC. No more this one. QO. This is anyway high temperature. I strike this. And instead of this 2, I put QH. Okay, instead of all, I put QH. So that's how it is. So let me take this QC and QH out. Sorry, QO out, and I will place H here. This one no more. Okay. I will take these pieces also out. COP now becomes, because QO plus QC is QH. I will put QH. Okay. Very nice. Okay. And a little moving upward here. then this way. Okay, it's very nice. And after that, I will do little more. I will do a little more modifications. So just have a watch on this. Okay. This 10 degrees C means the low temperature. Okay. So I will do more general one. Instead of 10, I put TL, low temperature. Okay. This 10, of course. 10. This 30 means high temperature. Okay, TH is high temperature. Okay, so it's the same. So compressor is here. This is the power or the work applying on this. And because of this compressor work, the circulation of the refrigerant through the components, compressor is receiving the refrigerant with this much of heat loaded for, let's say, for 1 kg. Okay, low temperature here. And somehow work done and transferring that heat to outside, higher temperature. Can you see receiving heat from low, transferring heat to high. Imagine refrigeration, you are taking heat or you are transferring heat from low to high, but natural heat transfer is from high to low. Natural. This is technology. The other way is natural. So I will put this way here. Let's see. High to low, this is natural. Yeah, anyway, I will take a new slide of this. I will take a new slide of this. Yeah, this is the one. So you can see, if you need to see the natural way, let me take it. And the technology. So I'm going to show you. Yeah. So 25 to 10 is natural. See, natural. And then here high temperature. So it's 45 or whatever. Here. So here you have one part, you have these two temperatures. Okay.
So are you talking?
Yeah, Buddha. Yes, talking. Very sorry.
Yes.
Very sorry. Thank you. Thank you. Yeah. So this is your QL. Okay. This is your TH. This is your QH. This is your WC. And this is your TM. Okay, this is your TM. So this is standard. So you do some work and then you remove heat from low temperature and pump heat to high temperature. So I'm going to take this picture out even. Okay, I'm going to take this picture out even and I will put a big circle here. If you are okay with this. Because this is a system, okay, this is a system. By means of system, you are pumping heat from cold temperature body to a warm temperature body, or low temperature, from receiving from low temperature, pump into high temperature. Okay, quite nice. But we came a long way to realize this. You know that this is reasonable for you. This should be something like Devaradega again. You should understand up to that level. Okay? You should understand up to that level. Okay? Good. So, actually now we are learning technology, you know. Okay. Okay. Good. Yeah, okay, Buddha. Thank you. I think the message is about. Okay, Buddha, I hope you can hear now. Eh? Yeah. Same thing. I have to do a little more housekeeping. So let me. Sorry, before housekeeping, I have to take this out. This is unnecessary one here. Okay. Okay, good. Let me take this part out. This is how we do evolve the concepts. Not to say concepts, these are technologies. But put these things. Yeah, this is very nice. Eh? Truck. So working fluid is essential. A system is there. That's nice. Since you know this well, now we are going to further simplify this. Okay. I'm going to enlarge this one. Transport is flowing through this and somehow releasing the heat. So I take this out. Instead of that, I'm putting something different. Even I couldn't see what I did. Yes. Even 45. I will put another TH dash. Okay, another high temperature, this one. Yes. I just took the compression out. Okay, this is another process. Let's see. Anyway, this is a bit challenging. Next, I take this. Evaporate out. I put it here. Another low temperature. Just put TL dash. Okay. And I take 10 degree out. Well, it's here. So this is natural. Okay. This QL is natural. This QH is natural. But 25 to 30 is unnatural. So next, I will take this compressor out. The reason is compressor is the power for the system. The component is the compressor, and compressor's power is everywhere. You understand? The circulation system got the power. Example, let's say heart. But you know that in the cardio system, throughout every blood vessel, wherever the blood flows, because blood has a power, it is from the compressor. So it's from the heart. So the heart's power is everywhere in the blood flow. Same way, the compressor power is everywhere in the refrigeration circulatory system. So for me, it is not necessary to draw a compression. Okay, I just put W. ඔය වගේ ටෙක්නොලොජි තේරුම් ගන්න එක තේරුම්ගන්න පොත්වල නැහැ කියලා. හදවතේ බලය තියෙන්නේ කොහෙද? බ්ලඩ් සෙල් බ්ලඩ් ෆ්ලෝ එකේ තියෙන්නේ. කේශ නාලිකාවල යන ලේ අංශුවකත් the flow එකේ තියෙන energy එක that is from the pumping power of the heart. In heart එකේ power එක තමයි දෙන්නේ flowing fluid එකට. Same way. Compressor, it's given to the system. I'm just applying this W on the system. Okay, so I would say that one way. So I took that out and return ready. Okay, return ready. I take this also out. It's okay because these are the because this has nothing to do with energy and work. So that's why I just take this out. Okay, can you see this? It's very nice. It's very nice. And then I will do some more housekeeping here. I will bring this to the center. Okay, I take this out. I take this out. I take this out. But I leave the truck here. Okay, I leave the truck here. And that is the expression for COP. I will take it here. QL over WC. Okay, that is QH minus because now you can say energy balance QL plus W. Okay, I will write no more WC now. QL plus W is QH. So nice. Energy balance. I'll put here. Because QL, W together comes to the system and going for unloading. Okay. COP is QL by W. Now, no more WC. Okay, QL by W and QL is QH minus W1B. Okay, this way. This. So we'll put it at a side. This is the COP or the refrigeration. Yeah. It is something like efficiency, but this is the cooling system performance. So we call this coefficient of performance. Coefficient of performance. Unit of QL, W all in SI units if that is watt or kilowatt. Okay. I take QH here. Reasonable. Okay. And let me add what this cloud means. You consider it's an ambient, but this is inside the fridge maybe. So low temperature energy reservoir. Reservoir means jalashaya. When it's jalashaya means reservoir means it has a collection of, if it's a water reservoir, it's a water body collection of water. energy reservoir means it's an energy body collection of energy. Here it is thermal energy. So this can be, yes, low temperature energy reservoir. Okay. What's the other one? This is high temperature energy reservoir. So heat is transferred from low temperature energy reservoir to high temperature energy reservoir. So that is what is being done by means of this heat moving technology. Tarathilani, see, you are learning the things very well. See how many students today, we have only 17. So sad to say the others are really missing this lesson. Yeah. One time if you learn all in one shot, why not? Okay, that's why. So this is excellent. Okay, this is excellent. It's an additional piece of knowledge, very valuable piece of knowledge you have gained. Okay, and the value, you have no words because we have developed this together. I didn't just put a figure here and explain to you, this is this, no such thing. Yeah, we together developed this. So together developing, it's different. It's different. That's why. So joining the class is very, very important. Each and every word important. Energy reservoirs. Energy reservoirs. One is low temperature, the other is high temperature. So what is your fridge inside? It's a low temperature energy reservoir. Reservoir means you are, yeah, it's an energy color. It's an energy body. The matter is there. Matter contains energy. So here it's thermal energy. Your surrounding is the high temperature energy. So your low temperature energy inside, you have to maintain it. So whatever coming from outside, you have to send it back. That is to the high temperature energy reservoir. Okay. So let's see if I need to get one more. If this is your refrigerator, if this is your refrigerator, okay, and this is being placed under this ambient. (30°C). Your refrigerator is let's say your refrigerator. I will put -10, -18, let's say. -18. So this is ambient, is a huge one, okay, huge reservoir. This is a limited one. So what happens is there is a natural heat flow from 30 to 18, -18, because high temperature, low temperature, you have a delta T. Because of the delta T, there is a heat leak from 30 to -18. Then what you should do, this is QL. You have to pump this back. You have to pump this back. To 30. This is QH. Okay. To get this, you should have a system. Okay, there is a system. There's a system. I will just put it here. There's a system. Okay. System receives some work. W. Okay. Okay, W. this QL received by the system and then okay, and then pump back, okay, and then pump back. This is received by the system and pump back. So how this pumps back? Here, okay. To the 30. Right? Yeah. So that's how it is. So you can see the low temperature reservoirs, high temperature reservoirs, the system receiving the work. Okay, this is the system receiving the work and receiving this heat QL. You can see this. Okay, and then the system send it back. Okay, so the indoor connection is the evaporator, the little smaller part I put there earlier. Smaller part. See. Releasing. You have this. Okay. You have this. So that's how it is. And even we can add the compressor here. No harm. Okay. Because compressor receives the work done as it's a dispatch, as it's receiving the dispatch power. Nice. Okay. You can see the cycle. So this is being operated in a cycle. Okay, this is in a cycle. It is 11:49. So we will take a break, Putana. We will take a break and we will start at 12. Okay, because this lesson is done and we have to continue about the transport, the rest. Okay. So this is 11:50 now. Take the 10 minutes break and see you by 12 o'clock. Okay? You will learn the similar important lessons because this will be in the exams. These are very standard theories. Now you see your textbook. You can say this model. Okay, in your notes. Okay, that's how you will say this. Okay. Is it okay? How do you feel? Any comments? Bimsara break එක ගන්නවද පුතා කොහොමද?
Okay, sir.
Okay. So we will take a break. 10 minutes. 10 minutes. So yeah, okay. 10 minutes break. So this is a master slide somehow. You can see this is very good. And I'm doing 2 more slides here. I now need 30 here. I now need 25. This can be any. So I took that out. But the sideways, that is okay as an example. But since this is a master slide, let me take this also out. Oh. Anyway, let it be. Okay, let it be. And let me share with you another important one before moving to understand the transport again. Okay. I'm reversing this. Okay. This system receives work. Okay. This system receives work and also not like previous. There is some heat. This can be leak or loss of heat. Okay. So the high temperature heat input, low temperature heat release. Okay. And this system produces some work. This system produces work. Okay. And then your energy balance is QH is let me this case QL plus W, it's the same. It's the same. But now your input is QH, output is W. Okay. So this could be energy input. See the arrow direction to the system? Energy input. Okay, last time input is work for the previous system. See W towards. And then because of W, this receives and pump heat. So here input is QH. Let's see. Input. QH. output is W. So QL can be what? Yeah, tell me. It can be a loss, or can be unused. For some technologies, there should be somehow unused components, okay? Lost or unused. So then you have, for this case, not the COP, but efficiency. Energy balance is the same. QH is W plus QL. Efficiency is your output is W. Okay? Your output is W divided by your input is QH. Efficiency is W by QH. Okay? W by QH. So W, one way you can have it as QH minus QL. Okay? So this is the efficiency term. Efficiency, if you need a symbol for efficiency. Efficiency is denoted by neta. Okay, neta here. Okay, now, straightforward lesson. Here, what are the applications? What are the applications? Power plants, steam or gas, what? Steam engines. Okay, steam engines. Or internal combustion engines, or the diesel and petrol, let's see. IC engines. Steam engine is external combustion. Okay. Then the gas turbines. Gas and steam turbines. Yeah. Okay. So these are the applications. Okay. These are the applications. Quite good piece of knowledge again. Yeah. So this is quite nice. No need this. Okay. So this is. So power plants, we have work output. W is there. That's why. Power plants, we have W. So I will take, I think, I'll bring this here. W. power plants and all. Efficiency is here. Okay, good. Yeah. I hope you can understand this quite fast because of the previous cooling technology knowledge. Okay, so these are for the power plants and yeah. So that is one, and I will take one more here. COP here we can mention as COP, refrigeration, REF, coefficient of performance of refrigeration. Okay, and sometimes we are using the same technology to use this QH. Then your output is QH, we call heat pump. It's something like the efficiency for heat pump. It is QH plus W. QH is QL plus W by W. Then this is for heat pumps. Okay. Here COP, refrigeration. Okay. Refrigeration. COP, refrigeration. It has little issue. Okay, very good. Okay, so this is some supplementary sharing of knowledge for you to understand. Your notes, Putta, good. Now only 13 remaining. Today by right there should be more. Never mind. Okay. So this is a very important piece of knowledge. And then back to the transport. Back to the transport. When it is ready to load, okay. So when it is ready to load, let me take this again. When it is ready to load. Quite interesting, eh? Yeah. Back to this. How fast? Okay. And per kg, the potential of receiving. Okay. QL. We know this QL very well now. How fast flow rate? Okay. How fast the flow rate? Very nice. And now we are going to understand, yeah, how fast and for QL. So what is the best matter for this? Yeah, so we are going to study the nature of refrigerants afterward. Okay, nature of refrigerants we are going to study now. Okay. This one. Okay. For the moment. So we will be focusing on, so what we need is the maximum QL for 1 kg. Okay, maximum QL. So then for 10 kg per minute, for 1 minute we can have the maximum possible when 1 kg has maximum. So let's see how to have maximum. Yes, maximum. QL for 1 kg. So that is very, very important. Maximum possible QL for 1 kg. Okay. Maximum possible QL. Maximum possible QL for 1 kg. So this is what we need. Okay. And also maximum possible QL means, so what kind of QL is this? Okay. So 1 kg for 1 kg, okay, QL received by when 1 kg, okay, mass of refrigerant is received QL is received QL. The mass is more energized, energized. The mass energizes, okay, and the flow conditions can be changed. Flow conditions can be changed. Yeah. Flow conditions can be changed. The biggest issue is there if the pressure rises while QL is loaded. Well, that is the issue. While QL is loaded. This issue, the biggest issue is there if the pressure rises. This is possible when the transport is in gas forms, when receiving QL. Why we say so? If the pressure rises, possible because you have certain limited space, because the space is limited, because the flow passage is limited. So this is the issue. Okay. This is the issue. If there is a pressure buildup during the loading time, imagine you are loading and your pressure is building up, or somehow that may disturb the flow. Okay. That may disturb the flow stability. This is one case. Yeah. That may disturb the flow stability. That's why matter in gas phase, matter as gas. Okay, matter as gas has this problem. Seriously. Can gas energy they are more excited. Okay, and they are going to have more space. They are going to take more space. So taking more space means there can be pressure buildups. If the pressure buildups is there, it's very difficult to let this flow. Okay, so gas is not an answer. Gas flow for QL is not an answer. Okay, gas flow for QL is not an answer. Okay, gas flow for QL is not an answer. And one more thing. Okay, one more thing is gas flow for QL cannot absorb, okay, cannot receive or cannot receive more gas flow for QL cannot receive in higher amounts. Can වැඩිපුර QL ගන්න බෑ in higher amounts. Because when the gas receives higher QL, excessive volumes can be experienced. Okay, can be experienced, and reaching the temperatures and rising the temperatures. Okay, temperature is rising of the temperature is significant. That is the other issue. Okay, let me explain this. Okay, yes, you can see this slide very well. See the cooling space is 25. Refrigerant flow temperature is 10. So you have a temperature difference of 15 degrees. Okay, temperature difference of 15 degrees. Let's say if this is gas And if entering is 10, what happens is halfway this will reach 25. So no temperature difference, halfway. And also more gas, more space occupied by the flow. Okay, that's why. So these are practical points. So gas is not possible because the internal temperature of the transport will rise. Then 25 minus, maybe 23 instead of 10. Halfway through here. So you cannot load enough. Or you have to have a huge, very huge gas flows. But still there will be temperature rising. So gas flow is not an answer. For you. So gas flow is not an answer. Okay. Gas flow is not an answer. Gas flow. See, gas flow I mentioned here. Gas flow. Gas flow is not an answer. Same way, liquid flow also the same. Liquid flow for QL. When the liquid receives higher QL, liquid also the same, receives higher QL. Not about the volume. Rising of higher temperature is significant. And halfway, okay, halfway, this may reach the higher temperatures. So temperature difference is not there. So the liquid also will not be an answer. So gas and liquid. Okay. So the next one is both. Let's see. Gas or liquid flow for QL cannot receive in higher amounts because when the gas or liquid receives higher QL, rising of the temperature of the gas and liquid or in the gas and liquid, gas or liquid is significant. Then what happens is your delta T your delta T your delta T your delta T initially maybe 25 minus 10 will be rising slowly, okay, can be changed to 25 minus 12, okay, and later can be 25 minus 15 and 25 minus 80. 25 minus 22. 25 minus 24. Because halfway your delta T can be changed. Okay. So here delta T example. Delta T may be 25 minus 10. 25 minus 10. Okay. Here maybe it is 25 minus 15. Here maybe 25 minus 20. And here maybe 25 minus 23 degrees Celsius. So you imagine the delta T is rising. So the potential to receive QL is reduced. So that is the issue. If you are using gas or liquid. Okay. And this heat we call sensible heat. Okay. So we call this sensible heat. Means when the heat is receiving, the temperature is rising means we can sense the heat by measuring the temperature. So sensible heat is something that is not very good for maximum loading of QL. Okay, sensible heat to receive QL is not effective. Okay, I hope you can understand this. That is how. When the heat is receiving, gradually temperature is rising. So this cannot be. Okay, this cannot be. So what is the choice? So what is the choice then? We should look into the latent heats. Okay, we should look into the latent heat. So latent heat. Because gas and liquid for QL cannot receive in high amount because sensible heat to receive QL is not effective. A solution. So the answer, what's the answer? Using saturated, okay, state liquid to receive QL in the form of latent heat. Okay, so this is the answer. This is the solution. So then small amount to have more QL. So that is maximizing QL for 1 kg latent heat. Okay. Liquid flow in the sense here, I will put subcooled. Subcooled. Let me see. Yeah, 12 are here. Put a subcooled කියන්නේ, let's say, water. What's the temperature? Average room temperature, maybe 25, 26, 27. What's the boiling temperature? 100. So water, anything below 100, we call subcooled. So subcooled water needs more heat to reach it into saturation condition water. Boiling means the water comes under saturation condition. Saturation condition means the water and the vapor at the same pressure, there is a balance somehow. We call saturation condition means a boiling condition. Okay. Once boiling all finished, again superheating. I taught you this one in the class. So saturated liquid is the solution to receive more heat. Okay, saturation liquid. Okay, so subcooled here, liquid flow subcooled. Okay, so subcooled liquid flow. So I'll put this here. Subcooled liquid flow. So gas is superheated. Okay, it is above the boiling. Gas means. So the liquid subcooled means cannot receive because the temperature will rise. Yeah. So the sensible heat to receive QL is not effective solution. So solution is using saturated state liquid, not the subcooled receive QL in the form of latent heat. Subcooled. So anything, even water can be used as refrigerant maybe. Water is classified as a refrigerant. So I will show you that too. Even water is classified as a refrigerant. There is a refrigerant code also for water. This one. This is solution. not effective. I take the word solution out. This is the solution. Okay. Now you know why we are using saturated liquids. Okay, saturated liquids. Because saturated liquids, the temperature will not change while receiving heat, latent heat. Because no temperature will rise until the last drop of liquid evaporates after receiving heat. Evaporate means turn to gas form. Okay, so that is the point. Okay, so you are using you are using saturated liquid to load this heat, and the refrigerant in the nature of saturated liquid receives this heat load with no temperature rise. Okay, and the other beauty is in the selected refrigerants, this value is quite high. There are higher values. Okay, so latent heat. Okay, latent heat. 12:49 is the time. Latent heat. Yeah. Let me open up the last PowerPoint for today. Latent heat. Heat can be seen in saturation property tables and is denoted as HFG. මතකද අපි HFG ගැන ඉගෙන ගත්තා? මතකයිනේ. HFG. HFG. So we are going to make use of HFG for QL. Okay, denoted as HFG. So that's the point. So using HFG for QL, for QL. Okay, using HFG for QL. So that is very important. So we will be learning this in the coming sessions, not only for QL. Once you have QL, as well as for QO. Okay, QO. So we are learning this afterward. Okay, as well as for QO. Yeah, that is very important. Okay. I hope you can say this, Putta. So this is the final slide. I have to do little. I will take this out. Okay. How about leaving it? Yeah, okay. Now you can say this. Good. So we know that in loading, and even when the transport is ready to unload, okay, passing through the dispatch. So all the heat should be in, all the heat mainly should be in HFG, especially for loading, and then generally for unloading as well. The majority of the heat is in HFG form, latent heat. Okay, latent heat, HFG. So I will save this. Save as S2B1. 30th December. 30th December. Nice. And if you want to see some HFGs, these are some. I will share the screen. These are the refrigerants. Okay. See, water R718, H2O water. So I can select any, okay, to show you. Maybe I will take R290, the latest one. R29004. 290 hydrocarbons, even nitrogen you can see, CO2 you can see, R600A. So whatever, yeah, I have the R290. This is the latest refrigerant with high HFG values. Here you have the HG value. Here you have the HL value. So difference is HFG. If you look into Rogers and Mayhew, you can clearly see HFG. But here you have to HG minus HL. This is at saturation. See, you can see saturated values for R290 or propane. Saturated values means at particular boiling temperature or at a particular pressure, when the refrigerant is boiling, the corresponding H values of gas and liquid, gas as Hg and liquid as HL is shown here. The difference is what Hg minus HL means. The energy received by liquid at that saturation pressure and temperature to turns into gas. Okay, saturated form gas. So this is HFG. So next week we will talk about HFG. And if you go through the other questions, there are 9 questions. Now you will find many answers out of this lesson we have done today. Okay, out of this lesson we have done today. So back to this, your questions. So we are about to see. Do you see the transport movement? Yes. Do you see the transport when it is ready to load? We are learning that one. While being loaded, we are learning. Dispatching for unloading, we are learning. So we are learning this, and I think this Friday session, we can complete this. Okay, Putana? Friday session, we can complete this because sometimes it takes time. So explanations takes time, but if it is one-time learning, we should say spending time is worthy. Spending time is worthy. And also go through your notes. Notes, very important. Always, when you are learning thermodynamics like subject, it's very important to go hand in hand with technologies, nature, the physical phenomena and all. And it is more than what's in the books. Okay, more than what's in the books. Okay, so transport refrigerant can be seen as trucks of 1 kg. So 1 kg to have maximum QL, that is saturated liquid at that temperature. Okay, means saturated liquid at that temperature means at that temperature liquid is boiling. Okay, or about to boil. Okay, so for that temperature to boil, you may need to bring the pressure down maybe. Okay, or at a pressure to make it saturation, you may need to bring the temperature up, same like what we are doing in water boiling to prepare a cup of tea and all, or in the steam power plants, whatever. Okay, see everything now you can feel very simple and nothing secrets. You have to unfold all the secrets and get all into the fingertips. But I'm going to stop the class. Before that, if you have any questions or anything, අද කරපු ටික තේරුණාද මට අන්න ඒකවත් කියන්නකෝ. පුතාලා තේරුණාද? Can you understand what we have done today? බිම්සර තේරුණාද පුතා?
Awesome.
Very good. Chatura.
Oh, sir.
ඔව් නේද? ටිකක් ස්ලෝ වුණා ඒ වුණාට පුතා මේ approach එක හරි important. මම මේ වීඩියෝස් මම දානවා මේ දානවා හොඳට කියවලා තේරුම් අරගෙන. ඔය කට්ටිය මීට වැඩිය හොඳ විදිහට මේවා explain කරන්න ඕන පුතා. තේරුණා නේද? That is what I am expecting from you. මේ වීඩියෝ එකත් මම දාන්න බලන්න this 4-hour plus one anyway I will try how to manage this. මේ ඔක්කොම ටික කියවන්න දැන් තේරෙනවනේ ඔය කට්ටියට ඒ කියන්නේ අපේ lectures වල note එක නෙවෙයි යන්නේ finally we will be completing this in style. මේ දැනුම exam එකේ බලනවා පුතා. මේ දැනුම exam එකේ බලනවා කියන්නේ ඔය කට්ටියට score කරන්න ලේසි. දන්නේ නැති. වචන ටිකක් ලියන්න විතරයි. Calculations උත්තේ calculations nothing. Don't worry about this. We have time. May Sikurada may take ඉවර කරලා once we complete this cooling technologies this Friday, hopefully we can complete the power plants as well. Okay, so we have to do some analysis, pH charts, then we have to learn about some other diagrams and all the Carnot cycles, ranking cycles, reverse rankings. Those are just names only. ඔක්කොම නම් විතරයි. තේරුණානේ නම් විතරයි මේවා තේරුම් ගන්න තියෙන්නේ. Gas power cycles, vapor power cycles. All very simple. You have to have this natural understanding. So understand what latent heat means. ඒක තමයි අද අපි නතර කරපු තැන. තේරුණානේ? Latent heat. ඒ කියන්නේ සෝබාදහමේ තියෙන දේවල් but some are of course derived by the science and technology through science and technology. Some are derived. HFG latent heat මේ ගැන ඉගෙන ගන්න පුතාල. Yeah, very simple. So steady flow energy equations we have done. Then the closed systems energy balances we have done. We know about the internal energies, entropies and all. Also work done in the expansions, PV diagrams we have done all. We have learned about the isentropic processes, polytropic processes, reversible, irreversibilities, equilibriums. We learn about the system surroundings. Yeah, we have done a lot, Puta. Okay, so this is so now we are reaching the final stages of this thermodynamics basics. And then afterwards we are moving beyond that. Okay. පුළුවන් තරම් තීරුම් ගන්න බලන්න පුතා. Okay. Very important. Right. Madhushani තේරුණාද පුතා? Can you understand? Madhushani. Sandhana. Isivar, are you okay, Puta? Isivar. Okay. Any more comments from your side? Okay. So we spend a lot of time here. Thank you very much. So I will upload this and please go through these videos, Puta. These are really helpful. I have to make the proper titles for that. So these will do whenever I feel, whenever I find enough time to do those things. But this one also I will try to upload. So one of the very good sessions we have done today. So thank you very much. Take care, all of you. Try to attend the classes regularly. That is very important. And also go through the videos. I will try to upload this video. And also, if possible, I will try to send this PowerPoint to you as well. This PowerPoint, I need to do some housekeeping because there are a lot of duplicate slides and all. So let me organize it and send it to you as well. But till then, surely tonight I will try to upload this lengthy video. So go ahead all. Thank you very much for joining the class and good luck to you all. Take care. Butana. Bye then. Eh? Bye.
Thank you, sir.
Okay, Butana. Bye.
Thank you, sir.
Thank you. Bye, Butana.
Thank you, sir.
Thank you, Butana. Bye.